happy Monday, guys. I'm in a meeting right now, so I have this video, and I will be available to talk about this a little bit more tomorrow, but I think today is a good day to sort of do a video, because I think you can figure a lot of it out yourself. Since we're talking about similarity, before we get into that, I want to talk about, give a reminder of the congruence shortcuts that we were allowed to use in the problem we did, congruency shortcuts. So I've got side, an angle, and a side. So I can say that these triangles are congruent by side, angle, side. Over here I've got these two sides congruent, these two sides congruent, and then do you remember the reflexive property that says that if things are shared among triangles that they're congruent. So since this side here is in both triangles, it's congruent to itself. So I can say these are congruent by side, side, side. Then over here, number 3, I've got an angle, and a side, and I've got these vertical angles here, angles that make an X, so I can say that these are congruent by angle, angle, side. And remember, I can't say that they're congruent by angle, side, angle, because in order for them to be angle, side, angle, the side has to be in between the angles. So the side would have had to be here and here in order for it to be angle, side, angle. But it is angle, angle, side. And then over here I've got an angle, and a side, and that is not enough. So this is not congruent. That wasn't anywhere on your paper. This is just a refresher of the shortcuts that we were allowed to use then. So we've got to talk about the shortcuts we can use today. I'm going to go pretty fast through this, so if you'll probably want to pause it at some point once these boxes are unplugged, so that you can fill some things in. So remember, in order to make a congruency shortcut work, we had to prove that the corresponding angles were congruent and the sides were congruent. All the pieces had to be congruent. Ones that we could use, side, 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 angle, angle, side, side, angle, side, angle, side, angle, and HL. Remember, we were not allowed to use angle, angle, angle. We were not allowed to use side, side, angle. Those were noted. The ones in black, those could be used to prove triangles congruent. Similarity shortcuts, you have to be able to prove that the corresponding angles are still congruent, we need that, and that the sides are proportional. They don't need to be congruent anymore, they just need to be proportional. Ones that work for this: angle, angle, side, angle, side, 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 side. And then the squiggly line means similarity. So it says angle, angle, similarity, side, angle, side, similarity, side, 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 similarity. These can be used to prove that triangles are similar. So here's how this works. Angle, angle. That tells us that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So over here I've got this one and this one, this one and this one. Because I've got two pairs of congruent angles, I can say that triangle ABC is similar to triangle DEF. And do you remember that when we make these statements, we have to do them in order. So if I did triangle ABC, and I went from 2 to 1 to none, I've got to do that over here as well. 2 to 1 to none. Now, you might ask yourself, why do we not need to prove 3 angles congruent? Why is there not an angle, angle, angle shortcut? I'm hoping you can recognize that because we know that there's 180 degrees in every triangle, that means that if I know 2 of them, the third one is going to be whatever 180 is minus those 2. It's automatically going to be congruent because there's only 3 angles. So if 2 of them are congruent, the third one has to be congruent because they all have to add up to 180 degrees. Side, side, side similarity. That tells me that if the corresponding sides of 2 triangles are proportional, then the triangles are similar. Now this one's a little bit harder to see without the numbers. So it's going to end up being a little bit easier once you don't have just side length. So basically it's saying if we make a fraction out of these two, and we make another fraction out of these two, and then make another fraction out of these two, and they should be the same. Remember, there's a couple ways you could do that. You could just simplify your fraction. You can see if you get the same number. You can cross multiply and see if you get the same number, but you have to cross multiply twice. I can say that triangle ABC is similar to EDF. And you'll notice that this time the similarity statement changed because of the location of my last one. Side angle side. This is side, side, side. Cross that out. That tells me that if there are two corresponding sides that are proportional and the angle between them is congruent, then I can say that the triangles are similar. It's got to be the angle between them. It can't just be any angle. So if I've got this and this that I'm going to make a fraction out of, they're not congruent. I'm going to make a fraction there corresponding. This and this, and then I've got an angle. Then it would work. So here's how this works. Remember that these theorems are similar to congruency theorems, so sometimes it's really easy to get them confused. But the trick is that the corresponding side lengths in similarity statements do not have to be congruent. They have to be proportional. You have to be increasing or decreasing at the same rate. Let's test this out. My first example. So what we're trying to do in each of these is decide whether or not these are similar. And then if they are, we've got to complete the similarity statement. The similarity statement is that triangle ABC is similar to the business. So it looks like I've already got a congruent angle. So if I'm looking at my options, I have side, 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 angle, side, angle, angle. I can pretty well rule out side, side, side already because there's an angle that's congruent and side, side, does not a common angle. So I've got to set up a proportionality statement. There's a couple ways you could do this. It's hard to know what goes with what when the triangles look like this. So I like to go smaller with smaller, larger with larger. So I'm going to put 36 and 63 together since those are smaller. So I'm going to do 36 over 63. And then I will put 91 and 52 together, but since I did the 36 first and the other one, I'm going to do 52 first in this one. 52 over 91. Now, remember, there's a couple of ways you could do this. You could just simplify the fraction down and see if you get something that works, or you could cross multiply and see if you get the same thing there as well. Does not really matter. So, if I were to simplify the fraction, over here, if I divide each of these by 6, oops, by 9, I'm going to get 4 over 7. Over here, if I divide each of these by 13, if I divide each of these by 13, I get 4/7. That means they're proportional. You could also cross multiply and see if you get the same number. I know some of you prefer that. If I end up getting the same number, 4/7 equals 4/7, that means these are proportional. These are increasing and decreasing at the same rate. So if I'm looking at my options, I have an angle already that I accounted for, and I have side, so I can cross out angle, angle, but I gotta make sure side, angle, side works. We're going to account for the fact that this angle is in between the sides I'm talking about, which in this case it is. So I can say that triangle BCD, so if I look at BCD, it's going from my angle, past my larger, past nothing. So I've got to do the same thing. From my angle, past my larger, past nothing. So this is going to be triangle WVU, and those are going to be similar by side, angle, side similarity. Example 2. Looking at my choices, I can already narrow some stuff down. If I decide if these are similar, I've already got a pair of congruent angles. So again, I can go to side, side, side. That's not going to be a time for. Now here, I'm hoping you'll remember that I've got a pair of vertical angles here. Now I've got two pairs of congruent angles. I don't need to do anything else. So I'm going to say, so EBC, that's going from 1 to 2 to none. I've got to do the same thing here. 1, 2 to none. Triangle EDC is similar to triangle EGH by angle and similarity. Example 3. Side, 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 angle, side, or angle, angle are my choices. First thing I'd like to do, I've got a pair of vertical angles in there. Now, you're going to have to remember what happens with parallel lines here. So if these lines are parallel, that means they're being cut by a transversal segment CS here. So that means I can say that a pair of angles, this one and this one, are congruent because they're alternate interior angles. Could also go the other way, and I could say D and T are congruent by alternate interior angles, but I didn't get that transversal. So now I've got two pairs of congruent angles. I don't need to do anything else. So if I went UTS, I went from 1 to none to 2. I can do the same thing here. 1 to none, 2. Triangle UDC by angle and similarity. Next one. I've got two triangles that I know nothing about in this case. Side, 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 angle, side, and angle, angle. Right away, I see that I've got a pair of vertical angles, so I can use those. And I've got two sets of sides this time, so I'm going to set up a proportionality here. I'm going to do small with small, larger with larger. So I'm going to put the 7 and the 28 together. And then I'm going to put the 11 and 44 together. If I divide each of these by 7, and I divide each of these by 11, I get 1/4. Remember, you could also cross multiply these and see if it ends up working. You get 1/4 equals 1/4. That is a true statement, so I can say that these are proportional. So I've got an angle, and now I can cross that out. Since I've dealt with some sides, I can cross that out. These are going to be similar by side, angle, side. I start with FED. So my vertical angle, go past my large side, past nothing. I got to do the same thing. Turn my vertical angle, past my large side, past nothing. FKJ. And side angle, side similarity. Alright, now this one's a little bit more complex. You got to make sure you're thinking through some things here. So I've got no angles that I can deal with here. I've got no vertical angles. I've got no corresponding or alternate interior, so I can pretty well cross out angle, angle, and I can even cross out side, angle, side if that needs an angle. I've got three sides. I'm going to set a ratio for each of them. I'm going to do small over small, large over, medium over medium, and large over large. So I'm going to put these two together. 60 over 104. And then I'm going to put, oh, that doesn't make sense. No, just kidding. 48 is smaller than that. 48, 1 over 4. I'm going to put 60 with 130. And I'm going to put 79 with 169. I got to check to see if all of these work. So you can simplify each of them, or you can set up two different cross multiplication equations. I simplify this one and divide both by 8, I end up getting 6/13. If I simplify this one and divide each by 10, I end up getting 6/13. And if I simplify this one, I don't think. I believe there's a way for me to get. Oops, this should be 6/13. I believe there's a way for me to get 6/13 here from this one. So because this final one here isn't the same ratio as this one, these are not similar. I'm not saying that these are similar. So you got a few more. I'm just going to put answers up, and I'd like you to test them out. If you're not getting the right answer, please consult with some peers and see if you can figure it out. After about 20 minutes or so, I've instructed whoever's studying this class to give out the homework. At that point, you can start working on the homework. But I would like you to give a few of these notes a try first. I'm just going to put answers, and I want you to see if you can get it. Okay, so for this example, if I set up 3 different proportions, I got these to be similar by side, side, side. Make sure you're setting them up small with small, medium with medium, large with large. This one, you could do it, there's 2 ways. You could do them similar by side, angle, side. If you remember that this angle here is in both triangles, so it's reflexive, angle L. Or you could also figure out, so you set something up like 10/5, that's this side over this side, equals 30/15. Oh, but you know what? I just realized what happened here. And then, so here's the problem. So crossing this off, this doesn't work. Because of this third set of sides here, 10/5, 30/15, 24/8, that is not the same fraction. So I was just kidding here. These are not similar. If I wanted to go side, 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 which I should be able to, my proportions don't work. We'll talk about that one tomorrow. That was kind of confusing. Number 8, I got similar by angle, angle. Just some vertical angles in there. Number 9, I got similar by side, angle, side. And number 10, I got similar by side, angle, side because this angle is reflective. So I set up the proportion that I would have set up here to make that work. If I want to make a note about this one, you are not allowed to use 12 and 15 because those are not actual side lengths of the triangle. Okay, I hope this makes kind of sense. If it doesn't, don't worry too much about it. I will go over it plenty with you tomorrow. Just want to make sure you have something to work on right now. So please make sure you're being nice. Hope you have a good day.